Hello and welcome to CET 4884. In this session, we will discuss the process of encryption and define some important key terms. Now remember that we do encryption so we can protect. We will identify and discuss common approaches to cryptography. The discussion will include the purpose of using cryptography and encryption as a technology to provide sophisticated approach to security. There are many security related tools use embedded encryption technologies. You can explore yourself the different available tools in the market to understand how it works and how it's being implemented. Knowing that encryption converts a message into a form that is unreadable by the unauthorized personnel will lead us to addressing the advantages and disadvantages of using cryptography. Again, we're not using the technical, or we're not doing the technical part of it, but we are understanding how it works, and maybe we will show some tricks on how cryptography works. Although not a specific application or security tool, encryption represents a sophisticated approach to security that is implemented in many security systems. In fact, many security-related tools use embedded encryption technologies to protect sensitive information handled by the application. For example, if you talk about the email, all the email servers or email let's say services that's been provided by Google, that's been provided by your company or by the education systems, all these are encrypted, so it has the encryption within those systems or within that application. Encryption is the process of converting an original message into a form that is unreadable by unauthorized individuals. So when you send an email, that email will be encrypted and will be sent to the other side to be received, and they will not be able to open it or see it unless they have the key to do that. So that's why when you send it to that person, actually it will go to that person, and only that person will be the only one to open that message and read that message. Those individuals can be defined as anyone without the tools to convert the encrypted message back to its original format. The science of encryption known as cryptology encompasses cryptography from the Greek word cryptos, which means hidden, while graphen, the second part of the word, means to write. So basically writing a hidden message. Cryptanalysis is the process of obtaining the original message or plain text from an encrypted message or cipher text without the knowledge of the algorithms and keys used to perform the encryption. The algorithm of encryption is the mathematical formula used to convert an unencrypted message into an encrypted message. Encryption is associated with many terms that we need to identify and understand, such as cipher. When we say the word cipher, which is the transformation of the individual component, characters, bytes, or bits of an unencrypted message into the encrypted component or the encrypted message. The cipher text or cryptogram is the unintelligible encrypted or encoded message resulting from an encryption. So whatever we encrypt, whatever result from that is called a cipher text. Code is the transformation of the large components, words, or phrases of an unencrypted message into encrypted components. Crypto system is the set of transformations necessary to convert an unencrypted message into an encrypted message. Decipher is to decrypt or convert the ciphertext to plain text back again so we can read it. The plain text is the original unencrypted message that was sent, that was encrypted and result from successful decryption. Encipher is to encrypt or convert plain text into cipher text. Key or crypto variable is the information used to in conjunction with the algorithm to create ciphertext from plain text. So we need a key so we can convert the cipher from plain text to a ciphertext. The key space is the entire range of values that can possibly be used to construct an individual key. Link encryption is a series of encryptions and decryption between a number of systems whereby each node decrypts the message sent to it and re-encrypt and then re-encrypt it using the different keys, then send the message to the next neighbor or next machine until it reaches the final destination. Now the other concept that we are going to address also is called steganography. Steganography is the process of hiding messages in a picture or graphic. Work factor is the amount of effort, usually in hours, required to perform cryptanalysis on an encoded message. So all these concepts, all these terms, you will hear about them as we go through the process of encryption and decryption. The notation used to describe the encryption process differs depending on the source. The first uses the letter M or letters M to represent the original message, C to represent the ending ciphertext, and E to represent the encrypted or encryption process. So if we want to put that in a mathematical equation, then E for M will equal to C. Again, if we encrypt M, if we encrypt M, the message, then the result will be a cipher text or the encrypted message. This formula represents the application of encryption to a message to create a ciphertext. So the other way around, so D represents the decryption or a deciphering process. Thus, if we would like to decrypt, then we will decrypt the encrypted message, which will give me the original message. K is used to represent the key. Thus, for each message that's been encrypted, it will be included with a key, or it will have a key that will be sent with a cipher text, so it will be used to open the message on the other side. It will be sent to that person only to be able to open that message. Now look at a simple form of encryption based on two concepts, the block cipher and the exclusive OR operation. With the block cipher method, the message is divided into blocks, that is 8 to 16 bit blocks, and then each block is transformed using the algorithm and the key. In encryption operations, the most commonly used algorithms included two functions, the substitution and transportation. In the substitution cipher, you substitute one value for another. That's why, or that's how we do the encryption, by taking some of the letters, some of the numbers, and replacing them with other numbers based on the key or based on the code that I have. So this is a simple enough method by itself but it's very powerful if we combine with other operations to encrypt the message, the original message that we have. So this type of substitution is based on mono alphabetic substitution, since it only uses one alphabet. More advanced substitution ciphers use two or more alphabets and are referred to as polyalphabetic substitution. Caesar reportedly used a three-value shift to the right, giving the particular substitution cipher his name, the Caesar cipher. Just like the substitution operation, or the transposition cipher is simple to understand but can be complex to decipher if properly used. Unlike the substitution cipher, the transposition cipher or permutation cipher simply rearranges the values within a block to create a ciphertext. This can be done at the bit level or the byte character level. This figure shows the what we call Wegener square, which was used for encryption, viewing the cipher as a substitution where a different alphabet was used for the next letter of the message, with the alphabets repeating periodically according to some key. So if we use these, we can see that there is a substitution for the letters. So if I just shift the letters here, and I can substitute A with B, B with C, C with D, and so on. So it depends on which number, which letter I use, then I can do a shift, and based on this square I can do encryption for the value. The transposition cipher or permutation cipher method simply rearranges the values within a block to create the ciphertext. This can be done at the bit level or the byte character level. Transposition ciphers move these bits or bytes to another location in the block, so that bit 1 becomes bit 4 and bit 2 becomes bit 7, etc. The exclusive OR operation, or XOR, is a function of Boolean algebra where by two bits are compared, and if the two bits are identical, the result is in a binary and it's equal to 0. If the two bits are not the same, the result is a binary of 1. I'm assuming that you know that binary system is from previous courses that you took in IT, that represents the 0 and 1. The binary system represents 0, 1 system. Also known as the one-time pad, the Vernam Cipher was developed at AT&T and uses a one-use set of characters, the value of which is added to the block of text. The resulting sum is then converted to text. When the two are added, if the values exceed 26, 26 is subtracted from the total module. The corresponding results are then converted back to text. The running key cipher is a type of polyalphabetic substitution cipher that uses text from book as a key to decrypt a message. In this case, the ciphertext will contain codes representing page, line, and word numbers. The algorithms or the algorithm of decrypting is the process of looking up the references from the ciphertext and converting each reference to a word by using the ciphertext value and the key. So I need to give you the key so you can actually do the decryption. This figure shows the various hash values that is being created by the hash functions. And the software that we use, it has to identify all of them, so whatever code being sent to whatever encryption, we will be able to decrypt the hashtags or the encryption that's being sent. Hash algorithms are publicly known functions that create a hash value, also known as the message digest, by converting variable length messages into a single fixed length value. The message digest is a fingerprint of the author's message that is to be compared with the receiver's locally calculated hash of the same message. And again, basically we are looking at the key. If the key matches, then you can open the message, or otherwise if the key doesn't match, you cannot open the message. So hashing functions do not require the use of keys, but a message authentication code, the MAC, which is essentially a one-way hash value that is encrypted with a symmetric, or we call it a symmetric key. The reception or the recipients must process the key to access the message digest and to confirm message integrity. If the message can be authenticated, then you can open the message and you will be able to decrypt or understand the content of the message. In general, cryptographic algorithms are often grouped into two broad categories, the symmetric and asymmetric. But in practice, today's popular crypto systems use a hybrid combination of symmetric and asymmetric algorithms. The symmetric and asymmetric algorithm can be distinguished by the types of keys they use for encryption and decryption operations. Symmetric encryption indicates that the same key, also known as the secret key, is used to conduct both the encryption and decryption of the message. Symmetric encryption methods can be extremely efficient, requiring minimal processing to either encrypted or decrypted messages. The problem is that both the sender and the receiver must own the encryption key. If either copy of the key is compromised, an intermediate can decrypt and read the message. One of the challenges of symmetric key encryption is getting a copy of the key to the receiver. Of course, you have to send with the message, you send the key with that message so the receiver can understand the message or decrypt the message and read it. A process that must be conducted out of band to avoid the interception. So it will be sent to the side or to a different. That's why we are saying that when you send it through an email, actually if you have an Outlook that you send to an Outlook, so you have a key going from one application to another. If you are sending from Google to an Outlook, then the key will be also translated from one services or from the mail services from one machine to another machine, and so on until we pass the key to the receiver so they can decrypt the message. This figure shows an example of passing an encrypted message between two persons using symmetric encryption. There are a number of popular symmetric encryption crypto systems. One of the most familiar is data encryption standard, developed in 1977 by IBM and based on the data encryption algorithm. Data encryption algorithm uses a 64 block size and a 56-bit key. The algorithm begins by adding parity bits to the key, resulting in 64 bits, and then applies the key in 16 rounds of XOR, substitution, and transposition operations. With a 56-bit key, the algorithm has 256 possible keys to choose from over 72 quadrillion. And this is a huge number of possibilities. The data encryption standard is a federally approved standard for non-classified data. Data encryption standard was cracked in 1997 when Rivest Schemer Alderman put a bounty on the algorithm. The Rivest Schemer Alderman offered a 10,000 reward for the first person or team to crack the algorithm. 14,000 users collaborated over the internet to finally break the encryption. Another category of encryption techniques is the asymmetric encryption, also known as the public key encryption, whereas the symmetric encryption systems are based on a single key to both encrypt and decrypt a message. Asymmetric encryption uses two different keys. Either key can be used to encrypt or decrypt the message. However, if key A is used to encrypt the message, only key B can decrypt the message. And if key B is used to encrypt the message, only key A can decrypt the message. The public key is stored in a public location where anyone can use it. The private key, as its name suggests, is a secret known only to the owner of the key pair. The problem with asymmetric encryption is that it requires 4 keys to hold a single conversation between two parties. Asymmetric encryption is not as efficient as symmetric encryption in terms of the CPU computations. As a result, the hybrid system described in the section on public key infrastructure is more commonly used instead of a pure asymmetric system. This figure shows an example of asymmetric system or encryption which uses the different but related keys. When using ciphers, one of the decisions that has to be made is the size of the crypto variables or variable or key. The strength of many encryption applications and crypto systems is measured by the key size. When it comes to crypto systems, the security of encrypted data is not dependent on keeping the encrypting algorithm secret. In fact, algorithms are often published so that researchers or research is to uncover their weakness, and it can be actually performed, research can be performed on these kind of algorithms. The security of any crypto system depends on keeping some or all of the elements of the crypto variables or keys secrets. This table shows the encryption key power with different key lengths, the maximum number of guesses. In addition, it includes the maximum time crack and the estimated average time to crack the code. And the bigger the length of the key, so here we have the key length in bits, and you can see as it gets bigger, it will take years and years to be able to crack it. So this is the time to crack it. If it's only a key with 8 bits, it can be cracked in a very small fraction of a second, very small fraction of a second. So we need to make it as complicated as possible. You can see it starts going very secured, or better secured when you start going with 56 bits and more. Although this one in 27 days, and 27 days it's still bad, but when you go to 64, you start going with 19.4 years. So 19 years, 20 years to crack this one, which is still good. But with 19 years now, with the current technologies that we have, if there is a software that can make the 19 years iterations in a few seconds again and make the simulation, then also that's not good. So we need to be careful with the number of or the length of the key, and make sure that it cannot be cracked easily. So that will be all for this session, and this is the first part of encryption and the cryptography. We will address more in the next session. If you have any questions, please let me know, and have a great day.